In a world where the technology is everywhere, what if a small wearable device can save a life? What if your parents or grandparents never feel alone when someone is not around? Hi, this is 𝐂𝐻𝐿 Embedded System Engineer at Crane's Varsity. Today I bring you something. It's not just a project, it is an emotion. Where Alzheimer disease. Alzheimer disease is a disease which occurs a brain neurological disorder. When people at the age of 65 they are suffering from Alzheimer disease, it is like forgetting recent events and forgetting how to take a medicine and how to take a food. So this is what we can build a wearable device. So today we are going to togetherly build a project IoT wearable device for Alzheimer disease. Imagination is an innovation. Imagine this: if your grandfather go for a walk, he doesn't come back, but he forgot the way, he forgot he has the diabetes, he forgot how to take a medicine because of Alzheimer disease. This Alzheimer disease is not only steals the memories, it puts a life in a risk. What if we can build a device that can monitor health like parameters BP, SpO2 and temperature, humidity? So monitoring this all the parameters, send data to the cloud. So this is all about IoT based wearable device. Now I will explain how you can build. Now let's talk about how it works and what is inside. So before going to do any project, so first we need to consider three parameters, such as first one is hardware implementation, second one is code debugging, and third one is prototyping. So in hardware implementation, so first we need to configure what all are the components is to be required to do the project. So our all components is depends upon our project objectives. So in this our project first objective is we are going to measure a health parameter such as body temperature, humidity, SpO2 and BP. So this is our first objective. Second objective is so after measuring all the health parameters, then we need to push a data to the cloud using ThingSpeak. And third objective is we are giving a continuous reminder to the patients using RTC driver. So after that, once the RTC module is been initialized with the CMOS battery, it will giving like real-time date and a time. So based on that, we'll keep every 3-hour alarm such as time for lunch and time for medicine. So after third objective is our real-time. Once the patient is fall, then we need to detect the fall detection and give the emergency alert to the caretakers. So this is all about our major implementations and our objective. So let's start. The brain of the system is ESP32 model. So this is the ESP32 model is a powerful microcontroller that connects to the sensors and upload data to the cloud. After that, this is a body temperature and humidity using DHT11 sensor. Then we are going to monitor heart rate and oxygen level using a max 30100 sensors, and movement fall detection will be measured by accelerometer ADXL335, and we are sending a real-time reminders using RTC module. So RTC module stands to be a real-time clock. So we are using specific real-time clock is DS3231. So we are using GSM 900, so used to send a message to the caretakers. So this is all about our project hardware implementations and components required. So now for fall detection, we are using Arduino Uno as a microcontroller, similarly followed by GSM 800C. So and ADXL335 is an accelerometer sensor. So here accelerometer sensor, as soon as we detect, then it will impact is been detected, then it is send a signal to the controller, then as soon as signal received by the controller, it send again signal to the GSM. So when a GSM is received a signal, then it will initiate the code to the user stating that your patient is fall down, so kindly take care. So this is all about a fall detection. It is also one of the objective. So after selecting a component, then we begin with the connection. So connection is based on connection table. So here components are one side and ESP32 pin diagram means one side. So here first we'll start with the DST11 sensor. So DST11 sensor is a sensor which measures the health parameters such as body temperature and humidity. So DST pin number out is going to connect GPIO 13 of ESP32 and VCC will be going to connect 3.3 volt and ground pin will going to connect ground of the ESP32. Similarly, MAX30100 pulse oximeter is a sensor which going to measure the health parameter such as SpO2 and BP. So here SDA will going to connect GPIO21, SCL will going to be connect GPIO22, VIN pin will going to connect a 3.3 volt and ground pin will going to be connect ground. Similarly, OLED display. Again, OLED display is also work on I2C. So again here SDA will going to connect GPIO21, SCL will going to be connect GPIO22, VCC will going to be connect 3.3 volt and ground pin will going to be connect ground of ESP32. Similarly, again RTC module is also work on I2C protocol. Again here same connection as OLED and MAX30100 sensor. SDA pin will going to be connect GPIO21, SCL pin will going to be connect GPIO22, VCC is 3.3 volt, ground is again ground. So now the question is how we all going to be connect SDA and SCL in one board. So we need to take a common connection from ESP32 in the breadboard. So SDA will take one common and SCA also will take one common using breadboard. Again as a buzzer for indication purpose, we are going to connect GPIO26 and ground will be ground. So Wi-Fi is inbuilt. Again ThingSpeak also we need to create one account on ThingSpeak so data can be uploaded using ThingSpeak. So here this all the connection based on the connection table. So after completion of the connection diagram with the help of connection table, then after we need to begin with the code debug. So here I written the code for the entire program and entire project. So here I included all the libraries which all are necessary for this project. Then here after I included my SSID and password. So SSID password is nothing but your Wi-Fi credentials. Similarly here ThingSpeak API key and ThingSpeak.com like ThingSpeak hotscom. And after that we'll begin with an initialization. So here all the initializations will come. Then once initialization is been done, here we'll set the timers like 15 and 30. So lunch alarm and medicine alarm. Similarly after the alarm is been completed, then we'll keep some buzzer for indication purpose. So this is all about our code. So how a program is start and how the temperature is going to be measured and SpO2, BP. So after measuring this all the parameters, we send data to the cloud. So with the help of this program, first we need to set the alarm for this project. So here now as per the time schedule 15, 30, 32 and 15, 34. So go for upload. it's take a time for compiling. So during the compilation, you need to hold the boot button. So after compilation, code is uploading into the microcontroller. As soon as code is been uploaded, then just click on a reset button. So Wi-Fi is connected. This is all IP address. Then RTC clock is being started. So there your time and date and will be measured, and here a temperature, BP and SpO2. Now you can check all the data on a ThinkSpeak. So in this ThinkSpeak you need to create a channel. So after creating the channel, so you need to visit your channel. Then here you need to create the field. Like I created temperature, humidity. Field 1 is temperature, field 2 is humidity, and field 3 is BP and SpO2. So here all the 4 parameters you have to measure. Then once the parameter is been measured, then go for data import. So here click on export and download your sheets. So as soon as your sheet is been downloaded, then you can visible your data. Like today how much we measure, each and everything will be followed. So date wise, here are the date, and this is the entry, how much entry you did till today, and this is the field 1, field 2, field 3, field 5, like that you need to get the overall data. So after measuring this overall data, we are giving access to the doctors. So based on this all the analysis and data, doctor will give the medicine to the patients. So this is what about our project. And after every alarm, it will show the time for lunch and time for medicine. So now you are seeing time for lunch. So here after 15:32, whatever the alarm we are initialized in the code, so that is been triggered. So now this is for a lunch time. After that, after 15:34, we given the alarm for the medicine. It is a time for lunch with buzzer. So after second alarm 15:34, it will print time for medicine. So this is both alarm we are giving for the patient, stating that first one is for lunch reminder and second one is for medicine reminder. So this is how RTC model will work to use the reminder purpose for the patient. So after measuring a health parameter, we start with a fault detection. So in the fault detection, we are using Arduino Uno is a controller and GSM for transmitting a message to the caregivers, and this is an ADXL335 accelerometer. So in this project, I have included a code. So this code is all about detecting the fault detection. First, you need to initialization the pin of GSM. So here I written 2 and 3 pin for RX and TX. While making connection, you need to ensure that RX pin will going to be connect TX of the Arduino, and TX pin will going to be connect RX pin of the Arduino. Similarly, this the connection for ADXL335 accelerometer. So A1 pin of ADXL you need to connect, X pin you need to connect A1, Y pin you need to connect A2, Z pin you need to connect A3. So after the connection, this is all the logic. So with the baud rate of 9600. So here as soon as this all the command 80 commands will be initialized, then we are giving a impact threshold value. So impact is been nothing but whatever the sensor data is been calculated with the help of ADXL. So we are giving some impact threshold value. So as soon as threshold will crosses, then the call is been initiated to the caregivers. So here when I tap the sensor in the command in the serial window, it will show how much impact is been detected. So we are giving 150 is a threshold value. So it crosses the threshold value, then after that it will take a call is been initiated to the caregiver. So here when I tap, here impact is been detected with the 150 magnitude, making a call initiated successfully. This is a call. So this is the fall detection all about. So this is how our entire project is going to be work with the help of ESP32 and Arduino Uno. So using a GSM implementation. So this is all about our entire project. This project is not just about the electronics. It is about giving hope to the families who lives fear in every day, and it's about giving independence to the patients and peace of mind for the caregivers. This is the power of IoT. Thanks for watching. Hit like and subscribe this channel for more embedded projects.